The purpose of this video is to demonstrate how to perform a calibration of an atomic absorption spectroscopy device. To begin, we must mix a base solution. This base mixture consists of 1,000 milliliters of distilled water and 1.1098 grams of anhydrous calcium chloride. The solution we had mixed has a concentration of 10 millimolars. However, we must dilute this 10 millimolar solution into 4 different samples, each being of a smaller concentration, with the highest concentration being 5 millimolars. We will also need to make 2 samples of each of the 4 concentrations. Here is a picture of our math and the proportions of water and sample that we had used. And here is a picture of the device that will perform the atomic absorption spectroscopy. Note that it is in a fume hood because a flame will be involved. To begin, you'll want to use the button in the bottom right to turn on the device. This is denoted by the red arrow. There should be a handbook provided near this device. It will list all the specifications of each metal that is used. And for this experiment, we are using calcium, so those specifications will be followed. To start, you want to go to the library option and pick the right type of element that you're testing. So we're testing calcium, so we select the Ca. Then press Update Instrument. Once again, make sure the specs are in fact correct. Now you will place the appropriate lamp into the machine, and since we are testing calcium, we will place the calcium lamp into the device. And you will do this by putting it in on the left side and opening the cap and then connecting the cap to the lamp. Make sure the lamp is securely in place. After you put the bulb in, the device needs to realign itself, so once you press the align button, just give it some time to let it run through. Once the device is properly aligned, we will normalize it. Once the normalize button is pressed on the screen, we can use the knobs on the left side, specifically the horizontal knob. We will turn it clockwise to adjust the blue bar to line up in the middle of the S. This might take a little bit of maneuvering. After that is done, we will press normalize once again. Now you will press 0 and exit to clear out of the screen and allow the device to reset itself. Before anything begins, ensure the tube is properly connected to the bin. Turn the compressed air knob anti-clockwise to open the valve. Once the compressed air valve is open, you can open the acetylene valve by turning it anti-clockwise as well. Turn the valve to turn on the air and ensure that the ball on the right is measuring between 4 and 6. Then you can turn on the fuel. Make sure the ball on the left meter reads at 4. Hold onto the flame igniter button until a flame actually ignites. Then you can go to the calibrate button on the screen and fill in your concentration values as you'd expect them to be. Set the concentration label to parts per million. Replicates refers to how many samples of each concentration you will test, so for this experiment we are testing 2 samples of each concentration, so you will set the number to 2. To get a baseline, place the tube in a sample of distilled water. Keep pressing OK to confirm the reading of the sample, and perform this procedure twice. Next, you can begin by using your actual samples and by starting from the lowest concentration. Just remember that since you are doing 2 replicates, you will need to take the tube out of the first sample, allow it to aspirate, and then place it into the second sample. Once the 2 replicates are taken, you can continue on to the next highest concentration. Ensure that you go from lowest concentration to highest concentration. So for this experiment, we had started at 0, which was DI water, and then we have made our way up to 5. Note how the color of the flame changes as you put the tube into the sample. Once all samples are tested, the absolute value for each concentration will be filled in by the machine. Calibration curve will be formed. Note that our concentration of 3 is missing. There might be some slight error, as the sample we tested in this video was 5 millimolars, but it read 5.2. This just shows more readings in the report section. To shut down the device, start by turning off the fuel. Then turn off the air. Close the acetylene valve first by turning the valve clockwise instead of anti-clockwise. Then turn the compressed air valve clockwise until it is turned off as well. To turn the screen off, go to the Controls section and press Shut Down. You have completed your atomic absorption spectroscopy test.